So in this lesson, we're trying to address the question of what topics appear in our fake news. We're interested to see if any particular topics come up that might help us identify a fake news article. For this, we're going to obviously be using topic modelling, and we're going to start by using latent Dirichlet allocation. The first step for us is going to be vectorising our text. We want to convert our text into numbers that can be fed into the LDA algorithm. So let's start by creating our fake news text, which is just going to be our dataset filtered to where fake or factual equals fake news, and then we're just taking our text clean column and resetting our index. This is just going to leave us with the cleaned up text from any article that's been classified as fake news. We then want to create our dictionary. So to do this, we use corpora.dictionary and then reference our fake news text. And finally, we want to create our bag of words. So we create our document term fake, and then from dictionary fake, we take doc to be of words over our text for each of our texts in fake news text. So we're going to jump straight into generating coherence scores to determine the optimal number of topics. So we create an empty list for our coherence values, and we create an empty list for our models. We also specify the minimum topics we want to test, which we'll set at 2, and the maximum topics we want to test, which we'll set at 11. Let's now create a for loop to run over each of the iterations of this model. So for num topics I, in the range from the minimum topics to the maximum topics plus 1, so from 2 to 12. We then create our LDA model, feeding it our doc term fake. Our number of topics will be specified to the num topics I for each of the iterations of our for loop, and ID to word is our dictionary fake. We then want to take this model and append it to our model list. From this, we can then create a coherence model for the model we're using in this for loop. So we use coherence model, model equals model, text equals fake news text, dictionary equals dictionary fake, and coherence is C_V. We then append coherence model get coherence to our coherence values. So what this loop will leave us with is a list of all our models in models list and a list of the coherence values put into our coherence values list. Let's now plot these coherence values to see what they look like for each of the iterations of our model using a different number of topics. We're going to use plt.plot, and we're going to be plotting the range from our minimum topics to our maximum topics plus 1 against our coherence values. We add a label to our x-axis for the number of topics. We use plt.ylabel for our y-label axis, which will be the coherence score. And we add a legend for our coherence values and specify the location. So we can see the coherence scores are highest when the number of topics was set to either 2, 7, or 11. For our example, we feel like 2 topics might not give us enough interest, whereas 11 topics is going to be too difficult to explain to different stakeholders and get an understanding of what those topics are around. So let's create our final LDA model with 7 topics. We specify the number of topics that we've chosen to be 7. We then create our LDA model. We use gensim.models.lda model as we used before and reference our .term fake, our dictionary, and our number of topics we want to use. We can then use LDA model.printTopics to print out the words that occur with each topic. We specify the number of words as 10. We want to see the 10 most common words for each of the topics. When we look through these topics, we can see that there is quite a lot of overlap. So, for example, the word Trump is a really frequently occurring word in all of the topics, as is the word said, and other words throughout there as well also appear in a number of different topics. In our next lesson, let's try some different techniques to pull out some more interesting topics and hopefully get some more insightful analysis.